So what you see here is the CAL5000 and its transport case, the test lead adapter kit for multiple vendors' equipment, the operator's manual, and the CAL5000 device itself. And then over here, there's a piece of test equipment whose output voltage can be verified with the CAL5000. That happens to be an insulation tester. This is what's commonly known as an AC high pot. So what we're going to do is go ahead and get out the leads from the multi-vendor adapter kit. There's three things you have to identify. One is there's a long wire with an alligator clamp on one end and a lead stab on the other end. That's going to be used to establish earth ground at this connector right here. So you can plug it in. Now we have capability to provide an earth ground to the test system. The second thing you need to verify is this dual prong banana plug. It's got a plug on each end of a cable. And if you look very carefully at it, you'll see right here where my thumb is, it says GND. That's going to plug in over here on the CAL5000, right here on this plug that's closest to the earth ground adapter that we just installed. So we'll plug it in just like this. Now we have provision to bring off a signal to a scope or a meter here. So this is an AC high pot device. You can see here it's got a selector switch where an operator can select different output voltages, and a overcurrent lamp or a warning lamp. A high voltage test lead, in this case it's been marked with white. That's the hot lead. This particular lead was marked with nothing, and it turns out by checking the vendor spec sheet that's the return. And then your AC mains input. It's important here to note that this is a three-prong plug. You can see that where my thumb is, there's an earth ground. So that'll be plugged into a standard NEMA wall outlet here in North America, providing an earth ground. So at this point, there's still a couple more connections that we have to make up. If you look very closely down here, you've got a labeled HV input with a schematic of a voltage divider to an earth ground. So this is the double banana plug that comes out to our meter. This will be our earth ground. But then up here we have a high impedance voltage divider based on a 1000 megohm resistor. So what we have to do next to make this work is we have to go ahead and locate one of our red jumpers, plug it into the HV input. So now we have a port that can accept a voltage input that we can measure. Now down here we've got our ground. We're going to use that as an earth ground, but we also may need to reference our test equipment to that same ground. So what's convenient here is we can take our black adapter, plug it in here. Now we've got two wires that we can make inputs from this high voltage tester. Okay, by now you're probably asking yourself, what do I do with the other end of the double banana plug? Well, here it is. You can see where my finger is. It's marked GND. That stands for ground, or common in this case. You'll put it into your meter. Just plug it right in between common and the volts input. A lot of brands of meters, and you have to select a voltage input. This particular one, we know we're dealing with volts AC because this is an AC high pot. So we'll pick a 0 to 20 volt scale. That's probably going to be appropriate because our 1000 to 1 voltage divider is what we're going to use to sample high voltage from this AC high pot and measure it on a standard multimeter. So next I'll hook up the test leads from this AC high pot. Remember, this was the hot lead. We'll connect that to the red input, like so. And then this was the return lead. We'll connect it to the earth ground input, like so. So here's the input circuit. On this particular type of tester, the customer labeled this with white. By reviewing the documentation, I determined that's the high voltage output. So you can see the red wire lands here on the HV input. Now the return on an AC high pot, we want a ground reference. So you can see it lands here on the ground reference jack. And one of the more important things that we're going to want to do is now we're going to want to make sure we provide an earth ground. This particular high pot has a metal enclosure with some convenient places you can clamp right to a bolt with the earth ground, and that way you get a ground from your chassis to your AC NEMA plugs. So now we're ready to do some testing, and I'll show how. Well, this particular device has this selector position. You can see 500, 1080, 1250, and so on and so forth, all the way over to 2500 volts. So the operator selects the output voltage they want to apply. I'm going to start with 500 volts. Now remember, we were feeding that voltage into this divider circuit. The output from the divider circuit comes over here to the meter, which is set up to read AC volts. So now I'm going to go ahead and come over here, switch this on, lamp goes on. That means output voltage is on the leads. I come over here and I see a signal of 0.52. Now remember, we have a 1000 to 1 voltage divider, so that's actually 520 volts coming out of that high pot right now. So this particular device suggests that you turn off the switch before you change the voltage. Now I'll do 1080 volts. Come over here, look at my meter. It says 1114 volts. I'll shut it down. I'll switch to the higher scale. Let's just do 1500 for now. Energize it. Come back over here. Look at the meter. It says 1.58, 1.59. That's equal to 1590 volts, and so forth. This particular device works all the way up to 2500 volts. Same concept. Turn it off, switch it, turn it on, verify your output voltage, 1.86, that's equivalent to 8. Again, the same concept. We kick it up to 2000 volts, energize, look at your meter, 2.12 volts, that's equivalent to 2120 volts. This type of low-end AC high pot has no regulation. So if your AC mains is a little stiff, like 122 volts as it is at EDE Electric, you'll get about 5 to 10% more voltage out of the high pot than you would if you were applying 115 volts to the input. So that's the kind of thing you have to keep in mind when you make these measurements. Just because it says something on the front panel of a particular tester does not necessarily mean that it's in spec. It may have been calibrated with a variac at the factory, say at 115 volts versus 122 volts. Kind of thing you want to keep